Okay, so today we are going to review oxidation, great handwriting, oxidation numbers. There we go. So first, what are oxidation numbers? The most easiest and simple definition is they're just the number of electrons that an atom has gained or lost. Gained or lost. And it is worth noting that all you have to do to calculate oxidation numbers are just look at a set of rules over here and look at a periodic table and do some mental math, of course. But that's pretty much it. So let's go to our first example, N3-. So an element by itself, it has no other elements with it, is 0. But of course you see the ionic charge over here, 3-, so the oxidation number will be 3 or -3. It is worth noting again that ionic charges are, it comes like 3-, and then oxidation numbers are -3. So they just flip around the sign and the number, but I don't know why they do that, just to make it confusing, but anyway. Okay. So let's go with the next example. Mg2+. There we go. So this one also is an element by itself, which is 0, but it does have an ionic charge, so it is 2+ again. There we go. Okay. Next example is Mg, again, MgO. So, magnesium over here is in group 2A, which is always +2. So we got a +2 right here. And oxygen is usually -2, but it is -1 in peroxide. And this is not peroxide, so it would be -2, which fits perfectly because the oxidation number should equal 0. So, there you go. Pretty easy so far. Next example is now we have NH3. Whoops. Okay, 3 was cut off, but you guys get what I'm talking about. Okay, so we have nitrogen over here, but you can see there's no rule for nitrogen. So what do we do now? We can look at hydrogen. So hydrogen is +1 with nonmetals and -1 with metals. Nitrogen is a nonmetal, so it would be wait, let's change the color for you guys over here. It would be +1. But there is a 3 over there, so we have to multiply it by 3, and then you would get 3 times 1 is 3. And this would equal 0. So nitrogen has to be something +3 and then equals 0. So you would have -3 + 3. You guys get what I'm saying, even through my bad writing. -3 + 3 equals 0. There we go. Okay, we'll just do this. There we go. Efficiency. Okay. Next we have CaC2. Let's go to the pencil. So we have calcium over here, which is in group 2A. And in 2A, it's always +2. So we can write a +2 over here. It does not have a number below, so +2. Just leave it there. Then, wow, construction. Okay. Then you can go to carbon times 2. So we look for carbon. There's really no rule for carbon, but we do know what calcium is. So we can equal that to 0, and it would be +2 - 2 equals 0. But because there's 2 carbons, you have to divide it by 2, you'd get 1. So in this carbon's carbon's oxidation number would be 1. So pretty easy still so far. Now let's go to the last example, which is a big one. H2P2O7. Lots of elements. Oh, and to add on top, a ionic charge of -2. So we know all of this is going to equal -2 at the end. We know that. We also know that H hydrogen is -1 with metals, and it is with potassium. I mean, not potassium, that's phosphorus. It would be +1 right now because it is with non-metals. So +1, but there's 2, so we multiply by 2, you get +2. And then phosphorus we don't know because there's no rule, but we do know oxygen, which is usually -2. So -2 times 7 is -14. That's kind of big. So we have +2 something -14 equals -2. Do some mental math and we can figure out that phosphorus goes right here with +10. 2 plus 10 is 12, minus 14 is -2. But we didn't figure out the phosphorus oxidation number, just 1 phosphorus. We figured out 2, but not 1. So divide that by 2. Great drawing over here. Equals 5. So you got 5, you got 2, and you got 1. Great drawings. Yes. So that's pretty much oxidation numbers. Got some good examples, and yeah, just follow the rules. It's pretty much all you need.